So as mentioned, the next talk will be a remote talk. Mehul is going to talk to us about reactive resources, schemas, generally Polaris data layer topics. And he really tried to be here in person, but getting a visa isn't always the easiest. So please welcome him as loud as you can. I think he should be able to hear you, but big round of applause. I'll hold the mic your way.
Thank you, everyone. Welcome to this talk. In this talk, we are going to talk about reactive resources and schema-driven data handling in using WarpDrive in modern Ember apps and other front-end frameworks. Reactive resources are reactive, explicit, and future-ready. This talk is going to be practical. We'll see real code examples. I'm hoping by the end you will understand how you can start migrating your large apps to use resource schemas, reactive resources. A bit about me, I'm Mehul. I work at UDEC. I try to make meaningful contributions to WarpDrive and Ember learning team sites. I love tinkering around pet projects. Something if I face some issue, I would like to build something for me. You can pretty much find me everywhere with this handle Mehul K Chaudhari on GitHub, LinkedIn, Twitter. Coming back to old world, where we now use data models, DS.models using Ember data in Ember apps. It works quite fine, but over the time, it has several pain points. It kind of feels magical. It's hard to understand what's happening under the hood. Debugging is hard. It has some hidden states and automatic behaviors. It was harder to customize. Uh, wo- that means it always felt like we are working against the framework. It was too coupled with Ember data assumptions and JSON API specs, whatever it is to follow. Many developers have experienced weird relationship or model errors. If you have, you know the pain. So since we are going all modern, we need some solution to this problem as well. And what's the alternative? Then WarpDrive brings in reactive resources. Instead of writing bigger classes with decorators, we define a simple JavaScript object, which is called resource schema. These schemas are just plain JavaScript objects that describe your data structures. No magic. You know exactly what's happening. It is fully TypeScript. It comes with TypeScript support, so no compile time errors. Debugging is much more easier as everything is very explicit. They come now. They support any type of API formats, REST, JSON API specs, or your custom APIs. This flexibility is huge advantage over old systems. This is how a basic resource schema looks like. We import with defaults function from WarpDrive core reactive. Here you can see it's a plain JavaScript object. We have defined IDs, first name, what kind it is a field, here what kind it is a resource. We'll in next slides we'll look into what is resource, what are fields. But for now, this is how we define our resource schema. This becomes a single source of truth. You don't need a serializers, adapters anymore, just schemas. These schemas serve a clear contract between your APIs and front end. It's reactive. Notice how explicit and readable it is compared to data models, decorators. This is called resource type. And here we have one ID, which is a resource key. Both this combine resource type and resource key works together to uniquely identify the resource. So whenever you're getting a resource from cache, it gives you the same resource and not the duplicates. Coming to object schema, object schemas are used to handle embedded data. If you'll see, we have a identity null, so they don't need to have a identity. This can be a standalone. This is not a standalone resource, so it is perfect for nested datas like addresses, coordinates, posts. This data still remains fully reactive even though it's embedded. You can reuse these schemas defined across multiple parent resources. This schema object tells WarpDrive this is an embedded object. It is much more cleaner than previous record approaches. Coming to field types, these field types are nothing but building blocks and basic primitive types like strings, booleans, numbers. Here if you'll see, we have resources, again collection. These are relationships. This is a belongs to relationship. This is a has many relationship. This is how we define in fields. This is how we define in a resource schema. Uh, it is what fields can do. This goes far beyond ds dot attributes. We have a schema object for embedded reusable subschemas. We have complex fields which can be array of objects, polymorphic types. Relationship fields belongs to is resource. As I said, we don't have resource here. There are traits. Traits are nothing but reusable snippets of fields. You can use it with multiple schemas. We have, if you'll notice, we have source key. This source key is nothing but if your API returns first name as first underscore name in a in a snake case, then you can map it with your camel case, and across the front end you can use it as first name. This unlocks main modeling, domain accurate data, not just flat models. What are complex fields? Complex fields let you model realistic shapes without making a top level resource, without making everything in top level resource. This is a schema array, nested schemas. This could be used in multiple schemas, and uh, it is a relationship of like embedded objects. Because they are a part of schemas, nested item participates in transform and derivations. They're still fully reactive. Common use case would be translation arrays, structure tags, etc. Editing this nested translation entry here uh, will trigger. um it is a basically reactive, so your UI always stays in sync, and UI updates automatically. Relational fields, these are belongs to and has many uh, relationships. If we'll see, schema records are expressed as resources and collections are, uh, so these are belongs to relationships. And if we'll see collections, these are has many relationships here. Relations can be included and depending on a request shape. Derived fields and transform can depend on a related source data. Because the cache stores the colonical identities, updating a related resource fields updates every place that it references to. Relationships are uh, these relation fields are great for deriving values, and that depends upon the related resources. Let's say if you have a user, so user dot post dot name, and it can go beyond that. What are traits? Traits are reusable snippets of code that you can use in multiple schemas. You can mix into multiple schemas. Uh, this keeps things dry and consistent. Traits may include complex or relation relational fields, but ensure types and transform align with it. What are derivations? Derivations replace our computed properties getters from models. We define it in schemas, and they they recompute only when the dependencies change. In next slide, I'll show you what all derivations can do. For example, if we want to create a username or a full name, you can define something like use these two fields and a separator as space. You can define these getters. Earlier we used to do it with getters. Now you can define it in schema, and now we have the logic centralized and you can use it across the UI. And these are recomputed when dependencies change. These are read only, so we ensure the data correctness. What can derivations do? They are, as I said, they are getters, cache getters. Derivations are powerful because they can return any shape, object, even functions. They can reach into related resources via cache to derive logic. They are always read only, never serialized back to the API. For example, if we need a can edit permission, for example, if we check it to let user edit something, so you can keep it here in derived fields and you can use it across app. So you don't need to recompute it. And whenever any dependencies change, uh, it will automatically update it across all the references of its usage. It's great for keeping business logic in schema instead of scattering all the UI components your usage. Uh, Now let's come to transformations. Transformations define bidirectional communication with API and app. In transformation, you can define both. You can do both serialize and hydration. Unlike Ember data, it does both ways. It ensures consistent and validated data across the app. It, it is useful for uh, some transformations like dates. If we take a ISO string from API and we need a date object, so we could play around like this, and it will be centralized logic, and you can use everywhere in the app. It is symmetric, as I said again, so it ensures the round trip integrity. What can derivations? What can transformations do? This example shows how we can manage multilingual data with map. Here, if we see, we have defined a transformation, translation maps transform. Here we are hydrating it data, we are creating a object from the value and serializing, we are back. We can register this transformation using this store.schema.register transformation, and we can use it in then we can use it in our schema, defining a field, let's say title field, and type could be translation map. How to use this translation now? We can use store.cache.pick, the name of field and the ID. You'll get this value using the getter title.getter, and you can set back using article.title.set, like this. Uh, this is this provides flat key value objects. A developer can use, of course, get set naturally, and UI updates are reactive. It again helps us keep the things in schema and not our UI logic scattered. Coming to extensions, let me warn you, this is for migration only. This is not for a new app which starts using schema records from reactive resources from first day. Uh, it's basically, it lets you use your old data, your old model classes, so you don't need to migrate everything at once. You can see in example that we are attaching a class and we are using this caution mega danger zone. It is explicitly made like that to make aware that this is for migration only. In on the next slide, I'll show you how we can use it, but majorly these are for migration, and it helps you reuse your old classes. Now, how to use extensions in practice? On the left side, if you'll see, these are our old data model. It has first name, last name, attributes. A has many relationship of friends, and we have three getters and a method. Sorry, two methods and a getter. With transformation, if you don't use extension, you will need to migrate all these in one go. But a, with extensions, you can register this class. So basically, you will define these fields: first name, last name, and a collection has many as it is, and then you can define it. If you are using any traits, you can import it and use it here. And you will define a object extensions. You can name it anything, but user colon extensions would be good thing. Then while you can register this schema using schema dot register resource, and when you need to reuse this uh, getters and the method, you define this caution mega danger zone register extension, and you define a object, name it user extensions, and in features you can reference this class, and now all your old methods are available to use with this resource schema. Once you are done migrating, pretty much your old models used to look like this, and with resource schema they would look like this. This is uh, this identity is automatically predicted by WarpDrive, so you don't need to explicitly mention it. If you want, you can. As we will see, we had a strings of first name, last name, and email. Here we have defined them and keep the fields. So primitive things, as we saw on the earlier slides, that we can define primitives, and the kind of those would be fields. Then we have defined a friends. Friends has many relationship. So we'll define what type of it is. It's a user, and what type it is. So collection, in case of has many, we use collection. Then we have a belongs to relationship of uh, favorite person defined like this, kind resource and type user. And we have a derived property, as we saw. Here we can define it. So derived property, as I said, that derived properties are cached getters. So this is a similar implementation of, this is how we can define it in resource schema. With the kind derived type, it would be concat. An option, you can say, you can define the fields you want to concat and the separators of it. This is pretty much it. Now we have seen how we can define data in resource schemas, the other types of fields in it, object schemas. But how do we make it come to life? How we can actually use it? This is how actually we bring them to light, with registering them on the store using store.schema.register resource. Notice we have a source key here, as I explained earlier, that if your API returns data in a snake case, and if you want to use it in camel case, this source key helps us to do that. We can plug, we can also plug in transforms like date time so that a raw string becomes a proper date object in JS, sorry. Relationships are configurable. Async decides if we load it eagerly or lazily. Um, Here in types collection, if we keep it polymorphic true, so it's a type of collection basically because pets can be anything, dogs, cats, etc. Think of this as a bridge where schema definition meets the runtime store. How you can use this reactive resource define? It's pretty much same as we used to do in models. We import find record from WarpDrive core utilities JSON API. This store.api is modern way to fetch data. We have shipped it long back. Many people among us would be using it now. Restructuring user data from the response and we can access properties like full name, team.name, sim normally as we do in JavaScript. You can still mutate properties and they remain reactive, but under the hood, there are no hidden states or magic. Everything is type safe thanks to schema definitions. The reactive system is explicit and predictable. This uses best of both worlds, familiar API with better internals. How data flows in WarpDrive. This diagram shows you how data flows through WarpDrive. API responses comes in, then we store it in cache. This caches uses schemas to understand the data structure, and reactive resources are created from this cache and cache data using schemas. Then UI components consume this data, and this is how data flows between what server sends and what UI consumes. When data changes anywhere in this flow, everything is in sync, very reactive. This is much more reliable than our old approaches with Ember data. Now, if you are using Ember data for a while, you might be having a lot of models, so you cannot migrate them at once, everything. So how you can set up using so you can start using resource schemas. Uh, for that we have this use legacy store. This works. This makes uh, this makes it possible to models and schemas coexist in an app while you gradually migrate to start using reactive resources. Um, and use recommended store. This is for the apps which are new, we just started using from the beginning. They started using schemas. This is recommended for new apps. Here it just suppose reactive resources and not the models. Uh, and this place exists because a team wanted to avoid forcing migration on day one. Legacy stores buys us that time, and recommended store is the future proof. So once you have migrated all your models to reactive resources schemas, then you can start use recommended store and get rid of use legacy store. What should be your migration strategy? Models and schemas can coexist using use legacy store. So during migration, we don't need to go very heavy on everything. We start with simplest resources like a few relationships, few types, few basic fields like first name, last name, and you can keep the bigger transformation, derivations, getters as it is, and use the extension hook to use the reference that class and use those for a time being. Create schemas using with defaults as I showed in earlier slides, and you can define the fields and primitive fields in those. Relationship would be a trickier part to migrate all at once, so we can migrate them gradually. Finally, when everything is migrated, we can switch to use recommended store, and this incremental step, this incremental approach reduces risk and allows through testing at each steps. Why this is better? Let me summarize. This is better because it's declarative and explicit. You can see what your data looks like. There are no mysterious behavior, no hidden states that models came with, and it was hard to debug. It has full TypeScript integration with users, autocompletes, and we avoid compile time errors. Uh, it's easier to debug because now we know how data flows, and it's very predictable. Uh, it it lets us use any custom APIs, not just the JSON API specs. And as far as I know, we might be shipping for a GraphQL as well. Um, this is built for modern web standards and optimized for performance. Uh, this majorly heavily increases developer experience significantly. So we spend less time fighting the framework and more time building the features. This represents a future of data handling in Ember and other frameworks like Vue, Svelte, React. Okay, we have come to an end very quickly. Thank you so much for listening so far. This was introduction to reactive resources. We have a comprehensive guide on WarpDrive documentation at warpdrive.io. You can read Run Inspired blogs for default drives. I recommend to read it. They're very good. We have as Chris showed yesterday, we have a migration guide in the documentation that would be helpful for me. Thank you everyone for listening. I hope this was helpful. And thank you team for helping me with this talk. This was very first time I'm talking uh, at the conference. Thank you again. Good luck with your warp drive journey.
Thank you. Are there any questions? I think we could do those. Yeah.
Do you have, alongside the structure definition, like you mentioned, the structure validation, like a field contains at least 4 characters, at least a field is an email, so you can have some regex or other type of validation, be a range between this number and this number?
We can define it in derivations. So you can check that there in derivations and you can define it. But I think Krish would be a better person to answer it.
There he is.
Yeah, somehow I can't escape this. I think your question, there's kind of 2 answers to it. Like one, it's like, what does data validation mean? Because are you validating the data coming from the server, or are you validating the data coming from the client? And depending on where you put that validation, it might be both. And you might think you want to validate data coming from the server, but that's actually a really bad idea because you're going to break your app in all sorts of unexpected ways at unexpected times. So there is a primitive in WarpDrive that you could use to write a validation layer. I would only recommend adding the validation layer unidirectionally, which is on mutation, and that's transformations. So on fields, you can add transformations. If you set the value, you run the validator then. So you'd write a transformation that's a validating transformation. Is that actually a good idea? I'm not really convinced that it is. Because more often than not, when you're trying to validate is very specific to the context of where you're taking the action in the app. And without that context, that validation may not apply anymore. So it's kind of a risky thing to put business logic that's or even more like product logic in your data validation layer, because that's just a different layer of your app. But do stay tuned, because I had some insights on this earlier, and maybe I'll do a lightning talk on that.
Well, I got a second mic. Now you're up there, so I mean
The question is for him, though. So.
of course, yes.
Hey, thank you for the talk, and a question probably for both of you guys. Kristen, in her talk at the beginning of the afternoon, she explained that WarpDrive now allows us to have locally mutable data, which, in my opinion, replaces Ember change set, which we extensively use in our application. Do you guys have documentation or blog posts to help us migrate away from Ember change set, if I'm correct?
I'll answer that one too. That's the same answer as the last one. If you take a look at what change sets was doing, it's two feature sets. It's a layer of validation and a layer of buffering. In the new world, we will do the buffering for you, but not the validation. And so if you still wanted the validation, you still need a layer to do the validation. So that you got to find somewhere for that. There is no clean migration for that yet. I am going to walk over there and put my name in the lightning talks. But for the buffering, it literally is just that records in Polaris mode never show mutated state, ever. It only ever shows the known good state from the server. When you run checkout, so like in Kristen's talk, she did await checkout of the record. That gives you a mutable copy. When you make that change, it only applies to that copy. It does not show on the immutable version. So everywhere else in your app, it will continue to just show the last known good state, which is what a lot of people were looking for out of change sets. So that gives you the ability to mutate all the fields you want to mutate as deeply as you want to mutate them, get the diff out, and use that to patch the state without ever needing to have another primitive. That's what we mean by it's built in. So the migration guide is just literally start mutating the record.
If you were to render a form representing a model you want to mutate, you would not pass the model. I mean, not the model, but the record from the cache, but the one you just spoke about, like the mutable one.
Yes.
Thank you.
All right, and with that, let's go into the break. One big round of applause for Mehul, and next time you'll be here in person. Hopefully.